This is today's bill assignment, so please pause the video for them. Whenever you're done, please put it on the board and go over them. Alright, lesson 73, we're talking about formulas for sequences. Recall that a sequence is an ordered list of numbers that follows a certain rule. In this lesson, we will practice using formulas to express the rule. Also recall that a term in a sequence has a value and a position. We distinguish between the number of the term, which is its position, such as first, second, third, fourth term, whatever, and the value of the term, such as 3, 6, 9. So term number, this is the sequence that we're talking about here. 3, 6, 9, 12, 15, 18. But 3 is the first term. 12 is the fourth term. 18 is the sixth term. That's what they're talking about there. We've already talked about some of this, so this should be a reminder, a review for you. We can write a formula that shows how to find the value of a term if we know its number. The formula a sub n equals 3n will generate any term in the sequence from this table. So this will get us any term from this sequence. In place of n, we substitute the number of the term we wish to find. Thus, to find the seventh term, we substitute 7 for n in the formula. So if we're looking for the seventh term, we substitute 7 for n. If we're looking for the 15th term, we substitute 15 for n, etc., etc. It goes on. Okay, so it says find the 8th and 9th terms of the sequence generated by the formula a sub n equals 3n. So we start with the formula a sub n equals 3n, and we want to find the 8th and the 9th. So if we're looking for the 8th, instead of n, we're going to plug in 8. So a sub n, which means 8th term, equals 3. And when we substitute for a variable, we open up those parentheses and we plug in what we're talking about, which is 8. So the 8th term, or a sub 8, equals 3 times 8, which is 24. Okay, so that would be the 8th term in that sequence. The 9th term, I'm going to take 9 and plug in this time. So I have a, instead of 9, or instead of n, I will plug in 9, equals 3, and instead of n, I will plug in 9 again. So a sub 9, which means 9th term, equals 3 times 9, which is 27. So the 8th term is 24, and the 9th term is 27. It says find the next two terms in each sequence. So we want to, first, before we can find the next two terms, we have to figure out what the rule is. So to get from 2 to 4 here, I could say plus 2. Well, if I take 4 plus 2, will that give me 8? No, it won't. So I have to find another way to get it. So instead, let's say 2 times 2. 2 times 2 will get me 4. 4 times 2 will get me 8. 8 times 2 will get me 16. 16 times 2 will get me 32, so that's obviously my rule. So I'm going to take 32 times 2, which will get me 64, and then I'm going to take 64 times 2, which will get me 128. Okay? On B, I have 1, 1, 2, 3, 5, 8. Okay? To get from 1 to 1, we could say we add 0. From 1 to 2, we add 1. From 2 to 3, we add 1. From 3 to 5, we add 2. That doesn't really make sense right now. Okay, this is what we call a recursive formula, where you have to use the terms previous. Okay, so here what we're doing is we're taking 1 plus 1, which gets us 2. Then we take 1 plus 2, and that gets us 3. Then we take 2 plus 3, and that gets us 5. Then we take 3 plus 5, and that gets us 8. If we take 5 plus 8, that should get us our next term, which is 13. And then we take 8 plus 13 to get our next term. So 8 plus 13 is going to get us 21. This sequence is called the Fibonacci sequence. Okay, it's a special sequence that math teachers, mathematicians enjoy. Okay, On the next one, ways that we can get from 1 to negative 2. I could say we take 1 times negative 2, but if I take negative 2 times negative 2, that won't get me 2. So it's not that. I could say I take 1 minus 3. So 1 minus 3 gets me negative 2, but negative 2 minus 3 won't get me 2. But if I take 2 minus 3, that gets me negative 1. So I could say that that would work. And 3 minus 3, did I say minus negative 3? Because if I did not mean to. I'm sorry. This is like my 12th lesson that I've recorded tonight, and I am ready to stop. So we're subtracting 3 every other time. So what are we doing on those other times? So to get from negative 2 to 2, I could say times negative 1. Well, if I do that, then that works for that one, but it won't work to get me from negative 1 to 3. So to get me from negative 2 to 2, I could say plus 4. Well, negative 1 plus 4 will get me 3. And 0 plus 4 will get me 4. So then I have to take 4 minus 3 to get me my next one. So 4 minus 3 is 1. And then I have to take 1 plus 4 to get my next one, which will be 5. Okay, so there we have found the next two terms of each of those sequences. A rule for the sequence in example 2 is, or in example 2a, excuse me, is a sub n equals 2 to the nth. Find the 10th term in the sequence. Once again, we're finding this the exact same way that we did earlier, which is going to be by plugging in whatever it is that we're looking for. So we're going to start with our a sub n equals, that's an n, equals 2 to the nth power. So instead of n, I'm going to plug in 10. So a sub 10 equals 2 to the 10th power. So the 10th term is 2 to the 10th power, so that literally means 2 times itself 10 times. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 4, 6, 8, 10. That worked. Okay, so instead of punching it into my calculator over and over and over again, I know some really quick ones, right? We hopefully all know that 2 times itself 3 times is 8. So those 3 would be 8. Oops, I didn't circle the third one. Okay. And then the last one, bring down that times 2. So we've taken care of 3 of them right there. So then I have 8 times 8, which gets me 64, times 8 times 2, which gets me 16. 64 times 16, I don't know off the top of my head. So 64 times 16 gives us 1024. So the 10th term, a sub 10, equals 1024. Final answer. Find the next 3 terms of the sequence given by the formula. It says the first 3 terms. So we're going to plug in 1, 2, and 3. So the first term is going to be a sub 1 equals 1 plus 2, and instead of n, we'll put 1. So we have to follow order of operations now. 2 times 1 is 2. Bring down everything else. So a sub 1 equals 3. The second term, I'm going to plug in 2. So I have a sub 2 equals 1 plus 2. Instead of n, I'll put 2. Follow order of operations. 2 times 2 is 4. Bring everything else straight down. So the second term is 5. Third term, I'm going to then plug in 3. So a sub 3 equals 1 plus 2. Instead of n, we'll put 3. Order of operations, we're going to get 2 times 3 is 6. Bring everything else straight down. So a sub 3 equals 7. So my first 3 terms are 3, 5, and 7. Last example that we have here is the numbers in this sequence are sometimes called triangular numbers. Those numbers are 1, 3, 5, or not 5, 1, 3, 6, 10, and 15. These numbers of objects can be arranged in triangular patterns. So we're going to do it with dots. So 1 dot is just 1 dot. And then with 3 dots, we have the 1 dot, and we complete it with 3. That's a triangle. Then for 6, we have the triangle that we just made. To get to 6, we add 3 dots. So there's the next triangle. Then to get to the 10, we have the 6 dots that we just had out here. And 6 from 10 is 4, so we add 4 more. So there are 10 dots there. Then we have the 10, so we list those out. That's our 6. That's our 10. So 10 from 15 is 5, so we add 5 more. Okay, see all of those triangles? That's why we call them triangular numbers. Okay, so they can be found using the formula. And why is it not there? What the heck? Well, the formula A sub n equals n times the quantity, n plus 1 all over 2. So it is A sub n equals n times the quantity of n plus 1 all over 2. And they want us to find the 10th term. So anywhere that there's an n, we're plugging in 10. Okay? So A sub 10, the 10th term, equals 10 times the quantity of 10 plus 1. Whoops, darn it. All over 2. So then we're going to simplify. I can do innermost set of parentheses first. So 10 plus 1 is 11. Bring everything else straight down. 10 times 11 is 110 over 2. A sub 10. So our 10th term is 55. Final answer. Okay. Homework for today is from lesson 73, A through F, and 6 through 24 even. If you are talking, that is going to change very quickly to all of the problems instead of just the even problems. Okay, have a good day. Please be good. Make sure that you have this ready to be graded first thing when you come in tomorrow.